Welcome back to the discussion and thank you for always joining us. KCSE 2018 Paper 1 number 22, a question on area approximation using trapezium rule. And the question we have reads, on the grid provided, draw a graph of y is equal to 4 minus a quarter x squared for the values of x between -4 and +4. Part B of the question, using trapezium rule with 8 strips, estimate the area bounded by the curve and the x-axis. Then C, find the area estimated in part B above by integration. Then D, calculate the percentage error in estimating the area using trapezium rule. We are going to start by drawing the table because you cannot draw the graph without a table. Here we are going to create a table having the values of x and y. We have been given the range of the values of x from -4 all the way to +4. And from there, we know that the first value is -4. The second value is going to be -3, -2, -1, 0, 1, 2, 3, and finally we are going to have 4. The reason why I'm using a range of 1 unit, it's because under area approximation using trapezium rule, the first thing we do is getting the height, and for us to get the height, we pick the maximum value of x provided, which is 8, which is +4, minus the minimum value of x, which is -4, divided by the number of strips. In this case, we are supposed to use 8. 4 minus -4 will give us 8, divided by 8, giving us a height of 1 unit, and that is what we have used on the x values. Once we have gotten the values of x that way, we can substitute those values of x in the main function for us to get the values of y. When x is -4, you take -4 to the main function, you substitute, and the value of y will be 0. When x is -3, the value is going to be 1.75. When it is -2, it will give us 3. When it is -1, you get 3.75. When it is 0, you'll get +4. And when x is +1, the value of y is going to be 3.75. When it is +2, you'll get the value of y to be 3. And when x is 3, you'll get y to be 1.75. And when it is 4, you get 0. Once we have these values, we are going to use the grid provided to draw our graph. Since we do not have that particular graph, we are going to simply sketch. I'm going to try and sketch this. The highest value of x is -4. So if this is -1, -2, -3, -4, and then we have 1, 2, 3, 4, that is on the x-axis. On the y-axis, we have the highest value being 4, so we can use a range of 1, 2, 3, and finally 4. Then downwards we have -1, -2, -3. And finally, you can also include -4. And when you are going to draw this particular graph, it will simply be a curve moving like this. So that is what you are expected to have from the plotting of all the points you can see there. Once we have done that, we are supposed to move to part B. And for part B, we are supposed to use trapezium rule with 7 strips to estimate the area bounded by the curve and the x-axis. Remember, area is given using half you multiply by the height into the sum of the ends. Then we add twice sum of the middles. That is a summary of the formula that we use under trapezium rule. Going back to the table, the first strip will be y0, the second one y1, y2, y3, y4, y5, y6, y7, and lastly y8. Therefore, our area is going to be equal to half into height times, that is multiplied by height into the sum of the ends. The ends is y0 and y8, then plus twice the sum of the middles, that is y1 plus y2 plus y3 plus y4 plus y5 plus y6 plus y7, which form our middles. Now we can substitute the values. We are going to have half of h. Our height is 1. Then we open the brackets. Y0 is 0 and y8 is also 0, so that we are going to have 0 plus 0. Then plus twice into the sum of the middles. Y1 is 1.75 plus y2 is 3 plus y3, that is 3.75 plus y4, which is 4. Y5 is 3.75 plus y6 is 3 plus y7 is 1.75. Once you have done that, you move down. We are going to have half times 1 will give us 0.5 into 0 plus 0 is 0 plus. We are going to have twice into 1.75 the way to 1.75. We are going to have 21, and 0 plus 2 times 21 will give us 0.5 times 21 times 2, you get 42, and 42 times 0.5, which is half, this one will give us 21 square units. Once we have the area from part B under trapezium rule, we are supposed to move to C and find the area estimated in part B above by integration. So C, the area by integration would be given by, we use this sign is for integration. We are supposed to integrate between x is equals to 4 and x is equals to -4, and the function we are integrating is 4 minus, we have 4 minus a quarter x squared, and we are going to integrate this in respect to change in x. Once we have done that, we are going to integrate. To integrate 4, we are going to take 4, then we introduce the variable x, minus, remember to integrate a quarter x squared, we are going to add 1 to the power, then we divide by the total new power, and this one is going to give us 1 over 12 x cubed. From there, now we introduce our limits as 4 and -4. Then we substitute the maximum value, we minus the minimum value and get the area anyway. So we are going to substitute the maximum value, which is 4. We multiply by 4 minus, we are going to have 1 over 12 into x, which is 4, and this x is cubed, then minus 4 into negative 4, which is the minimum value, minus 1 over 12 into negative 4 cubed. If you simplify these values, we are going to have 16 minus, that is 64 over 12, minus, this is negative 64, that is negative 16, sorry, minus, and this one is going to be plus 64 divided by 12, translating to the first one will give us 10 and 2/3 minus the second one will give us exactly 10 and 2/3, and this one is going to be minus is a plus, which is going to give us 21 and a third square units. Once we have gotten that, again, we have answered that particular part very well. And we are going to move to the last part, which is part D, calculate the percentage error in estimating the area using trapezium rule. So in this case, to get the percentage error, we are going to take the exact area, which is 21. Exact area is worked out using integration, minus the area using trapezium rule, which is 21, divided by the actual area, which is 21 and a third, and this way we are going to multiply this by 100. This way, now we are going to have 21 and a third minus 21, which will give us a third, divided by 21 and a third times 100, and this one is going to give us 1.5625% as the percentage error in calculating the area of the above region using trapezium rule. Thank you for watching and welcome to our discussions. And in case you are watching this channel for the first time, please take a second or two, you click the subscribe button so that anytime we publish a video like this, you will automatically be given a notification. Thank you and welcome.